The basic principle is used in Miller-Rabin primality testing, as well as some other things. It's not always called the basic principle, but it was in my book. It states, first of all, that suppose n is an integer. Right here we have n is an integer, and there exists x and y such that x squared is congruent to y squared mod n, but x is not congruent to plus or minus y mod n. When this is the case, we can say n is not prime, or n is composite, because there is a greatest common divisor between x minus y and n that is in between 1 and n. This is obviously, since if something bigger than 1 is dividing n, it's not prime. We can also use this as a primality test in some ways. For example, if we say n is 35, right? Suppose n is an element of the integers. Over here, n is 35. Since there exists x and y, for example, 12 and 2, such that 12 squared is composite to 2 squared, or is composite to, excuse me, 12 squared is congruent to 2 squared mod 35. This is true. However, 12 is not congruent to either plus or minus 2 mod 35. Therefore, we can say that 35 is composite.